In this video, I'm going to be describing the relationship between the slopes of parallel and perpendicular lines. Let's start off with a pair of points here. Points A and B are going to be on the same line, and we're going to call that line AB. Another pair of points, points C and D, are going to be on the same line, so we're going to call that line CD. We're going to find the slope of these two lines and compare them. So to find the slope between 2 points, we subtract the y values on top and subtract the x values on the bottom in the same order. So 2 minus 5 is -3. -3 minus 2 is -5. And a negative divided by a negative simplifies to a +3/5. For line CD, if we subtract the y values on top, so 2 minus -4, and the x values, subtract them on the bottom in the same order, so 8 minus -2. On top, we got 2 minus -4, which becomes 2 plus 4, which is 6. 8 minus -2 becomes 8 plus 2, which is 10. And 6/10 reduces, if you divide top and bottom by 2, to 3/5. So now we can compare our slopes. They seem to be the same. They're equal. Let's plot these points. If I plot point A at 2, 5, and I plot point B at -3, 2, then I have line AB here. If I plot point C at -2, -4, and point D at 8, 2, then here is line CD, and we can visualize that they do look parallel. And because their slopes are equal, or the same, they're actually never going to touch. If this line is rising and running in the exact same way that this line is rising and running, they will always be going the same direction and they will never cross. So parallel lines will always have the same or equal slopes, or if I think about that backwards, lines that have the same or equal slopes must be parallel. What if we have equations of lines? How can we find which of them are parallel? So in this example, we have 3 different lines, and we're given the equations of them. If I can compare their slopes, I could determine which of these lines are parallel. So let's put these equations in slope-intercept form so we can look at their slopes. The first line is already there, y equals mx plus b. And the slope of this line is 2. So if I can find other lines that have a slope of 2, then it will be parallel to line 1. Line 2, if I can solve for y and put it in slope-intercept form, then I would be able to look at its slope. So to solve for y, I need to multiply both sides by the reciprocal, -1/2, or I could divide everything by -2. 4 divided by -2 is -2. 6 divided by -2 is -3. So now we got our equation in slope-intercept form, and the slope is -2. So not equal to the slope of line 1. Those two lines are not parallel. Let's check out line 3. To solve for y, I need to add 1 to both sides. I wish I could scoot this over here. So I'm really adding 1 to both sides, not adding 1 to the left side twice. So adding 1 to both sides gives me x plus 1 on the right side and leaves behind 1/2 y on the left. To get y by itself, we would multiply both sides by the reciprocal, multiply everything by 2. So 2 times x is 2x, 2 times 1 is 2. So our equation is y equals 2x plus 2. So the slope of line 3 is +2. So because line 1 and line 3 have equal slopes, they must be parallel lines. Let's talk about perpendicular lines. Do the same experiment. Let's take 2 pairs of points, points A and B, call it line AB, and find the slope. So let's subtract the y coordinates on top, -5 minus 2. Subtract the x coordinates on the bottom in the same order, so -2 minus 3. -5 minus 2 is -7. -2 minus 3 is -5. And a negative divided by a negative simplifies to +7/5. So the slope of line AB is 7/5. Let's take our pair of points C and D, say that they're on line CD, and find the slope of that line. Subtract the y values on top, so -3 minus 7. Subtract the x values on the bottom in the same order, so 10 minus -4. Negative 3 minus 7 is negative 10, and 10 minus negative 4 turns into 10 plus 4, that's 14. Negative 10 over 14 reduces if we divide by 2 to negative 5/7. So now let's compare those slopes. So they're not equal. Perpendicular lines don't have equal slopes. Let's see what they do have here. How do they compare? 7/5 and 5/7 are what's called reciprocals. If I flip 7/5, I get 5/7. 7/5 is positive, but 5/7 is negative. We call that opposites. So these slopes seem to be opposite reciprocals of each other. Let's plot these points. If I plot A at 3, 2, and B at -2, -5, then I have line AB here. If I plot C at -4, 7, and D at 10, -3, then I have line CD here, and they definitely look like they're intersecting in a perpendicular relationship. So perpendicular lines actually have opposite reciprocal slopes. They got to be both. They can't just be opposite slopes. That's not perpendicular relationship. And they can't just be reciprocal slopes. That's also not a perpendicular relationship. They have to be both opposites and reciprocals. And if we have slopes that meet like that, they will always meet at a 90-degree angle or a perpendicular intersection. One more time, let's take a look at equations and see if we can determine which of the equations here are perpendicular now. So now we're looking for opposite reciprocal slopes. And again, we're going to want to solve these equations, put them into slope-intercept form so that we can look at the slopes. So to do that with line 1, I'm going to subtract 2 from both sides. That leaves 2/3 y on the left, and now we have x minus 2 on the right. To get y by itself, multiply by the reciprocal of 2/3, so multiply everything by 3/2. 3/2 times x is 3/2 x. 3/2 times -2, that's 3 times -2, which is -6, divided by 2, which is -3. So the slope of line 1 is 3/2. We're looking for opposite reciprocals. Let's take a look at line 2. To solve for y and put it in slope-intercept form, I'm going to divide everything by -2 or multiply everything by the reciprocal -1/2. So 3 divided by -2 is -3/2. 6 divided by -2 is -3. So the slope of line 2 is -3/2. Well, positive 3/2 and -3/2 are not opposite reciprocals, they're just opposites. So line 1 and line 2 are not perpendicular. Let's take a look at line 3. Line 3 is already set up for us in slope-intercept form. The slope is -2/3. So -2/3 and -3/2 are just reciprocals of each other. They're not opposites. So line 2 and line 3 are not perpendicular. Let's take a look at line 1 and line 3. -2/3 and positive 3/2. Those are reciprocals and they're opposites of each other. So line 1 and line 3 must be the perpendicular pair because they have the opposite reciprocal slopes. So there's the relationship of slopes of parallel and perpendicular lines. Perpendicular lines have opposite reciprocal slopes. That's what creates this 90-degree intersection. And parallel lines have equal or the same slope. That's what helps them never intersect and stay parallel lines.